Hey, welcome back to my lab. A couple of years ago, I did a few videos on this binary coded decimal Thumbwheel switch. I believe I made a couple of test projects using LEDs and Nixie tubes and whatnot, so I'll put links to those videos in the description below. The original intent of buying these switches was to build a decade resistor kit or a decade resistor stack. Although when I got these units, I realized I bought these BCD versions of these switches by mistake. So I ended up keeping them and repurposing these switches for projects like Nixie Tube Tester and other projects internally. A week ago, I bought these. These are decimal coded Thumbwheel switches. I have a few of these that I bought. And the way these work is similar to the binary coded, except these operate on a decimal basis, so that there are 9 numeric or 10 numeric nodes and one common node. Let's see if I can get you even closer view of this. Yep, there you go. So there's a common node in the middle, and then 0 to 4 and 5 to 9 on either side of the common pin. These will work really well for building a decade resistor kit or a stack. And the way this works is identical to the binary coded switch I showed earlier, except the contacts within the PCB board behind the scenes has far more contact points that the wiper blade would get in touch with as it rotates along the axis, and then it makes a contact with the corresponding decimal value that you would pick. So I bought a whole bunch of these actually on eBay. You can stack them up or stack them up side by side. What I'm hoping to do is maybe doing a 6 or a 7 node decade resistor. But what I'm hoping to do is building this with not with the through hole resistors, but rather using some SMD resistors that I have in my lab. By using SMD resistors, I can make this more of a low profile format. That's number one. Number two, I'm also hoping that the resistors I end up using have low tolerance percentage values so that it's much closer to the value that these numbers will end up representing. The other day I went and bought this on Amazon. It comes in these storage boxes. These are 1206, and I believe with 1206 you can get better tolerance levels. The kit here, they're all 1%. So I need to see if they're truly 1%. So I believe they range from 0R all the way to 10 megs. So should be a good kit for what I'm trying to do. 1% is pretty good, to be honest. So let's see. I'm going to test a couple of these and see what the true tolerance levels are. I'm hoping they stay true to the advertised tolerance level. So let me get that set up and I'll be right back. So here I have 9 buckets of these 1206 resistors. Let me get you guys a closer look. Alright, hopefully that'll show up good. 0R, 1R, 10R, 100R, 1K, 10K, 100K, 1 meg, and 10 meg. So a total of 9 of them. I'm not sure, to be honest, I'm not sure where one would use a 0R. I don't know if that's meant for correction. Let's say if there's something was off, you probably would put something like this in series to kind of fix the offset. I'm not sure. If you guys have any suggestions or guidance, let me know. So what I have here is a close-up view of one of these thumb wheels, which is I soldered earlier. The way I'm soldering these is in this staggered way. Just keeps it easier to kind of solder them together. This is not the best soldering job in the world, so take it with a grain of salt. But the point is that the common and the zero nodes are not connected. These two nodes are used to stack the other thumb wheel switches with each other. Let's say if this was a first thumb wheel in the lowest denominator, if you will. C would be one of the terminals and 0 would be linked to the next thumb wheel switch in the stack. The very last thumb wheel switch and its 0 will become the other terminal. So you'll have two terminals. One would be the first thumb wheel switch is C, and then the other terminal would be the last thumb wheel switch is 0. Take a look at this 4 and the 5 nodes. They need to be connected up with another resistor. I took just a regular low tolerance resistor. Let me flip this around quick. So in the back, I took that regular 100K resistor in this case, and then I soldered node number 4 with node number 5. So what I have here is a brand new thumb wheel switch, as you can see here. I'm going to place this solder paste right between 0 and 1 to start off. That should be plenty good. I'm going to place this right there and then gently tap it down so it doesn't move too much. Note that I did not put any solder on the other leg of the resistor yet. And I'm going to take my soldering iron, hold the resistor down with my tweezers gently, and let it heat, and then let it be. The way I solder the other leg on the resistor is to take a regular soldering wire. I'm going to bring the soldering wire closer to it. That should be plenty good for now. The next one would be to, again, taking a shot of this solder and place it on the lower section of the node number 1. Place right on 1, like so. Take my soldering iron, hold down the resistor with my tweezers gently. And there we go. And then take my regular soldering wire and that should be it. So let me finish this off and then I'll come back and then I'll show you how I put them all together. So the far right is the 1R, and I went all the way up to 10 megs here. So A couple of points, and I've learned this during the course of building this and then testing, etc. So I was a little bit disappointed in the tolerance levels for each of these SMD resistors. They were definitely contrary to the to what was advertised. So in some cases, I've seen it in the 5% delta, and most of them are relatively close to just a tad over a 1% tolerance. So that's okay. But those that were in the 5% delta, that wasn't acceptable. In any case, long story short, I was able to complete it. What I have here is one of the leads coming in from the decade resistor and the other one here, and both of them are connected up to the DMM here, and I've set it up to be a 2-wire test point for now and see how it performs. Tilt this up just a little bit here. Alright, so that might work out great. I think the DMM is kind of blurry in the back. I hope that'll be fine. Let me first start off with the 1R here. And as you can tell, it's 1R. It kind of fluctuates between 0.99 to 10 in the range there, so that's fine. And let's go to 2R, 2.06, 3R, 3.05, 4, 5R, 6R, 7R, 8R, 9, and 0, right? Okay, all right, so let's move to the next one, which would be 10R. So actually, let me go back to 0. Let's do a reset here. 10R, 20R, 30R, so that's 29.92 ohms. 40R, I hope you guys can still see it. Let me maybe zoom out a little bit. That might be better. All right, 40R, 50R, 60R, 70, 80, 90R, back to 0. All right, let's go to 100R, 100R, 200R, 300, 400, 5, 600, 700, 8. So that switched the range to, let me show you what I mean. Like I described in my previous video, the meter changes the range from ohms to kilo ohms. So as you can tell in the bottom there, it shows 6K ohm is the range. All right, so let me zoom back here. All right. Okay, where were we? Yeah, 800R, 900R, which is 0.89 kilo ohms here, back to 0. Now let's go to 1K. That's 1K, 0.9993 Rs is 1K for, that's looks like, that delta is actually pretty good, to be honest. 2K, 3K, 2.9951, 3K, 4K 3.9957, 5K 5.0092, 6K, 7K, 8K, 9K, back to 0. Okay. Let's do 10K, 10K, all right, 20K, 30, 40K, 50, 60K, 70, 80K, 90K, back to 0. Now let's do 100K. That's 100K, 99.96. It kind of fluctuates between 100 point something to 99.96. 200K, 199.46. That's a big delta in my books. That's a little bit away. Anyways, 200K, 300K, 400K, well, that's a big delta also. 500K, 600K, 700K, 800K, that's 0.79 megs, 900K, 0.8982 megs, and back to 0. Let's go to 1 meg. All right, 1 meg, 0.9948. Let's go to 2 megs, 1.9966, 3 megs, 2.99, 4 megs, 3.99, 5 megs, 5.01, 6 megs, 6.01, 7 megs, 7.01, that's been pretty consistent. 8 megs, I've noticed this, when I switch to 8 megs, it takes a little while for it to kind of come to its settling point, right? It takes a while, at least 2 to 3 seconds there. Anyways, 8 megs, 9 megs, back to 0. Let's go to 100 megs, or rather 10 megs, my apologies. 10 megs, 9.991, 20 megs, 19.845, that's a little bit of a delta there. 30 megs, 29.75, 40 megs, 50 megs, 60 megs, 70 megs, 80 megs, 90, that's pretty good actually, back to 0. All right, so I'm gonna change this all to, let's say, 999,000. Okay, that should be close to 100 megs. So that's pretty good actually. Anyway, so that's a quick run through the testing here. So let me quickly turn this around and show you the business end of the, or the back end of the decade resistor here. And let me get that set up and I'll be right back. In the back end, you've seen the SMD resistors, and you've also seen that I've used the standard through-hole resistor for the bridge between the for node number 4 and node number 5, and you're seeing some of that here. A couple of things I want to draw your attention to is the way I linked these Thumbwheel switches together is by connecting up the 0 node to the common node onto the next one, and then the 0 node of the next one goes to the common node of the next one. Likewise, the 0 node of this node goes to the common node of the next one. So 0 goes to common, except for the very end, of course. That becomes the terminal. And also the exception is the very first one. The common becomes one of the terminals. So really that's it. Nothing fancy going on here, to be honest. And I want to maybe do a quick view of, if I can get a better focus on this. I hope you guys can see that. I hope this was useful, and we'll talk soon. God bless.